Hello, my name is Rich Howard, owner of Architectural Builder Supply, and this video is to bring you a closer look at the Norton 7500 SS, their corrosion-resistant model of their flagship series door closer, their 7500 series door closer. The 7500 by Norton is their big hammer, so to speak. It's the closer, the top of their line closer that will basically do everything, comply with everything, be that one closer that you're going to use in practically most instances. And because it's their top line, grade 1, heavy-duty door closer, all of the features, all of the arm conversions, all of the templating, all of the different possibilities of how to install a door closer have been engineered and designed into the 7500 line, permitting you to be able to accommodate a particular requirement, whether it be a flush panel or a deep reveal, or in this case, a corrosion-resistant version of that closer. So this is a 7500, but it's the SS version. Now the SS adds additional features onto the 7500. The 7500 base model is going to be a tri-packed model that will allow you to install the material into a regular arm, parallel arm, or top jamb mount. It will be a non-handed closer. It will be a rack and pinion style design closer, which is a reference to the internal construction type of the door closer. Rack and pinion versus cam would be a different video in terms of the design construction, but this is a rack and pinion design with a cast aluminum body, and that will make it lighter versus a cast iron body. And there is an argument to be made that the more hardware that you add onto a door, the heavier it gets. And some people like to hold a really heavy cast iron closer body and say, that's quality. Is it quality? I don't know. Airplanes are made of aluminum. So you would certainly argue that having less weight on the door itself is a more beneficial thing for the user. Obviously, the life of the door, the hanging hardware like hinges, the closer itself, pulling the door closed. This is adjustable sizes 1 through 6, and this has a relatively short projection of 2 3/16. It features staked valves, and staked valves are nice, which when we look later at the valves that will control the different types of ranges of opening and closing cycles, the staked valve is there to prevent you from removing that closer valve stem out so far that the fluid will escape. So a staked valve is a feature of a high-end closer, making it idiot-proof. I've done that before. Loosened that set screw out so far that it was still in the closer body, and I went to cycle it. Well, that fluid just pushed the the set screw out. It went flying, oil all over my shirt. Staked valves would have prevented that problem. Retrofit plates are going to allow you to install this over lots of different current other manufacturers' models of closers, previous models. An item they call Norglide fluid. Norglide. And let's give you some features of what that Norglide fluid is. And the Norglide fluid is a marketing term that they use to say that the fluid that's within the closer body is formulated for efficient door closer operation and optimum performance. I would extrapolate that to mean whatever they called the prior fluid probably didn't work well against its competition or work as well as possible. So they, turned it into a marketing opportunity, I would say. The fluid complements the interaction of the door closer's aluminum housing and its steel and brass components, while maintaining stable viscosity to allow the door closer to perform in a temperature range as from extremely high to about 40 below Fahrenheit. It's a fluid that's going to be used that will be compatible with the way it's manufactured and the way that a person's going to install it. It's helpful to have a steering wheel that's round because that works really well. And it would be helpful to have fluid in your door closer body that would be equally compatible. So they'll call it Norglide fluid. Will feature a molded plastic cover, and on the 7500 series you can certainly get into steel covers, whether you want something more durable in terms of, imagine a restroom at a campground, which would be a great application for let's say a southern climate, maybe something near the coast. This would be a great application for a 7500 SS. Metal cover that you can have prime coated for you to paint it, or it can be sprayed, or it can be plated. But instances like that, there's an opportunity for vandalism. So something a little more durable than a plastic cover. Will then, as I said earlier, this series of closer will give you all of the capabilities of different arm and application types, which we'll touch on later. The 7500, though, that takes it to another level in the sense that the 7500 is going to give you brass adjustment valves, a 440 grade stainless steel pinion shaft, which basically means that it is an improved chromium alloy intended for high temperature corrosion oxidation resistance. You can do an internet search to find out that the 440 grade stainless is a higher grade containing more carbon, allowing for much better edge retention if it's used in cutlery, but ends up being, when heat treated, a very durable alloy of stainless. So improved materials is, I think, what they're going for there. Because the pinion shaft, the 440 grade stainless steel pinion shaft, that's where all the energy is going to be done between the door closer body, its rack on the inside, the pinion shaft, its rack, and it's going to transfer all the energy to the arm, therefore to the frame or to the door. All aluminum body and bronze closer arm bushings. All other components are of 302, 303 grade stainless. Fasteners are 818 stainless, and is going to come in a tri-pack only, which means that the subcomponents in the arm for a 7500 SS are not available on all of the other broad array of arms that are available from Norton. Okay, so basically you're going to have a closer that's going to be more appropriate for a environment rich in salt, a coastal environment. Maybe something that will have extreme temperatures because of that Norglide fluid. Door closers will fail and fatigue with exposure to extreme environment, and having the internal components of this with an upgraded pinion shaft is going to give you a fighting chance for it to simply last longer. And why do we need a 7500 SS? Well, it's because we, as hardware users, install them in environments that regular hardware is not really, I don't think, meant or should be expected to last forever. And you really do need to upgrade all the internal componentry when you are knowingly using it in an environment. This closer, there's two of them actually on the order, are going to a client in Singapore where it's a resort community. It's on the beach, and it's going to be in the summer, salty, public use, not public, but public use at the resort all year long. And it's properly specified by the client. They understand the application, and they understand the advantages of the SS version of the 7500, and immediately determined that it was the proper closer to go with. Now, there is a link below this video to the product catalog where you can go over basically everything I've just gone on and on about. And you'll be able to review all of the applications of the 7500 but we're going to start now with an overview of the parts, a visual tour. The next portion of this video is going to be a visual tour of what the 7500 SS looks like. First of all, weighs 8.5 pounds. That's what the entire package weighs, and that is substantially less heavy than a cast iron closer body. I can tell you that. It's likely approaching 50% less heavy. So that's something to be important. That's something to be aware of. It does matter. You're adding all that weight to a closer, or to a door. Just taking the components out as I encounter them in the top of the box. Installation instructions, which we're going to go over next after the visual tour. Visual and dimensional tour. Installation instructions will occur after that. You've got your arm. You've got your main arm and your forearm here. Now they state that there are there is absolutely a difference in this arm. It is not the standard arm, the arm that will come with the 7500 SS. That is absolutely sure. The link to the product catalog will show you that its arm has its own page. The bronze closer arm bushings are going to be obviously on your pieces of material that are going to make contact with each other. Obviously, here at the elbow between the main arm and the forearm. Okay. We have some loose fasteners in the package. Yeah. Tiny little opening here in the package is what permitted them to escape. But according to the manufacturer, you're going to have all stainless steel components for the fasteners. And obviously you're going to have machine screws and wood screws permitting you to install it on any of the material. They're sticking out. Alright. Sharp points and plastic don't mix. So not only all of the screws that you'll need to connect the body to the door or to the header, but you're going to get the nuts and bolts to attach the arm to the top of the pinion shaft. You'll get a wrench to adjust the valves, which we'll go over. And then, of course, the fasteners to get the rod shoe down to whatever you're attaching it to. And we're going to go over the different mounting types as well. Okay, now let's take a visual tour of this closer. And certainly starting with the business end of the closer is where it'd be most appropriate to start. The cover and the cover will always be wrapped in plastic, okay? And will be fitted over the closer body itself. Okay, so we have lots of valves. We've got 4 valves. We've got spring adjustment. Let's take a look at this closer. Everything's indicated on the face of the closer in terms of what the valves are. You've got the L valve here, the tip of my finger. Want to make sure that I describe these correct. And this being a model without delayed action, the valves are defined as follows. I'll hold it from the back side. You've got L here for latch. That is basically the first 10 degree. Okay. You've got, in a non-delayed action, you've got a valve that's marked SD. You'll notice that there's nothing in this position. SD simply means the sweep. It's basically from about 10 degree to about 85 degree or so, something in that range. And those two valves will allow you to control the speed at which the closer moves 0 to 10, 10 to 85, latch and sweep in its closing cycle. This closer has back check, which is the B valve that's here. It has a P valve as well. Back check is a control that exists on a hydraulic closer, not all, but those that have back check, that from about 85 degree, the forceful opening of the closer is arrested. What I mean to say is, imagine if you have an exterior door that swings out. You've got the 0 to 10 latch, you've got the 10 to 85 sweep, but then there's a gust of wind. The back check valve will actually work to limit the aggressive opening nature of a door at that point. Very helpful. It's not a dead stop, but if you were to open the door carefully through its cycle, you'll notice that when you get to the back check, when that's set, it will take more force to push the door open. That's really important because it's a feature to a door closer that is incredibly helpful in those applications where it's exterior outswing. You don't, by the time the door gets to 90, it's going to be moving quite fast if you measured the speed of the door, and you will benefit from having a valve that's out at that 90-degree range to help slow it down, slow it down. Now, the other valve that's marked P is the position, which is normally closed, but you can adjust the position at which the back check will begin to operate. You might have a need in your application. You might have a door in the back of your building and you take deliveries, but you do want to open it to 120 degree, because you want that door to be open a bit so that you can come out with your two-hand wheel cart. So you might modify the position where back check works to basically divide it out of the equation of controlling the closer from its normal, about 85 degree, and opening that up a little bit further. So that's why you might use the position on this. Now your spring adjustment, and we're going to go over the spring adjustment when we get to the installation aspect. It's this nut that's on the end here. And that basically will allow you to control this from a 1-size spring to a 6-size spring. And as you tighten that or loosen that, it literally works to compress the spring so that when the rack and pinion moves inside of it, it's dealing with a spring either this compressed, this compressed, this compressed. Okay, so it will obviously change the force that it acts on the rack, acting on the pinion shaft, acting on the arm, acting on the door ultimately. Okay, let's do some dimensional properties. You'll know in Norton 7500 when you have this type of footprint, and I'm not looking at the template, but the screw holes are basically just shy of 7 inch on the width, maybe 6 3/4, and then about looks like about 2 3/4 on the height. Closer body projection itself, about just shy of 2 inch. Then it's going to have an overall length of about 13 inch. Okay. A nice feature of door closers in this day and age is that they put just the information you need right on the cover. Okay? Because let's say you're a maintenance person and you've got 300 doors that you are in charge of keeping working well. You've got 5 different manufacturers of door closers installed because of the phases of how this building was built, let's say, over years. It's really helpful to just not have to remember that stuff and have the instructions right there. Okay, it's a heavy, it's a plastic closer, but it does give you the impression that it's durable and heavy, and does seem to be of substantial thickness as far as plastic goes. These knockouts here is where the pinion shaft is going to exit the top of the closer or the bottom of the closer, so you might have to reposition this filler piece over here, but that's normal and standard. Overall width of the closer body, of the cover, 13 3/4. Overall height, about 3 7/8, with an overall projection, about 2 inch. Maybe a little heavy on 2 inch. This arm, just generically, going to have an overall length of about 23 inch. Now, this closer, it's important to know, this client specifically ordered this as a regular arm closer, and the soffit plate, or what's known as the parallel arm bracket, was not in the box. The point of the matter is, be very clear when you're ordering it. If you order a regular arm closer, it's very likely, as I had stated earlier about them being tri-packed, you will not. They will actually pull this plate out of the box. Okay? That's really not for them to save another parallel arm bracket, but it would be correct, and it would be appropriate to supply hardware as specified, not having additional parts. A, it's incorrect, because you're not following the definition of what's specified. It does invite the potential for an improper installation. I installed it with the parallel arm bracket. You put it on the wrong side of the door. Well, you sent the bracket. Okay, so that's not helpful to anyone. So that would be why these two closers did not come with a parallel arm bracket, because they were specified to be compatible with a regular arm or a top jamb mount only. And in those two instances, you absolutely do not use a parallel arm bracket. I have pulled one from the shelf for visual review, really. And an overall length of the parallel arm bracket, about 4 7/8. Overall width, about 3.5 inch. Okay. I just simply want the video to include that information. And then again, your screw package. Looking through here, you have all of the long screws are obviously for the body itself, because they need to get through that 2 inch dimension to get into the door. So those screws are probably going to be in the 3 inch range. I can see that we have the screw from the arm down to the pinion cam, which would be here. There's going to be a washer included in there for that. You'll have screws when it is set to accommodate a parallel arm bracket for the parallel arm bracket itself. You'll obviously have the screws for the arm shoe, these two holes that are here. This can be adjusted based on the application, and that's really a reference to a top jamb mount when we're talking about reveal, which we'll get into. And that concludes the visual review of the 7500 SS. We're going to move on to reviewing the installation instructions next. Now, the next part of this video, we'll go over the installation instructions. And installation instructions for door closers are generally pretty much all the same. The format and the contents of the information in the installation instructions always include a description of the components that are included. You'll always have a page that says, here's what's in the box. You'll have an overview of the closer, something generally brief that you need to see. You'll always have definitions of the valves and how to set the spring. Sometimes that's on its own page. Sometimes that's literally added to the last component, which are the types of mount that you'll have. Regular arm, top jamb arm, parallel arm. When you're dealing with a tri-pack style closer, rather than a specialty closer, meaning it has a specialty arm, a specific unique arm. Okay, so you'll have what's in the box, a summary of the closer, how to control it, adjust it, set it, and then how to install it. 6 components, six components, and there are indeed 6 pages in the installation instructions. Let's start to review what this looks like. So first of all, there's a notation, and this closer is adjustable from size 1 through 6, as outlined in ANSI A156.4, which defines the requirement of what a closer needs to do to be handicap compliant. When you adjust the closer to have a reduced opening force of 5 pounds for interior doors, exterior doors do not have that same mandatory obligation, you may have an inadequate amount of closing force to get the door closed. The bottom line is a reduced opening force, easier to open, equals a reduced closing force because of that spring. How much you set the spring, how much you compress it, is how easy it is to open, and therefore how much torque the closer has on board when it's releasing its energy, when the spring is expanding to close the door. An exterior door is an application that is not going to be required to comply, but there are ways to make an exterior door comply, such as adding an automatic door opener, a handicap operator that will remove the force because it's literally opening the door for you. Okay. An application of where this could be problematic with the need for handicap compliance is you may have a air pressure condition that exists in the building where you are literally requiring more force to get the door closed, meaning you have to turn that spring power up, increase the opening force to make it something that will be compliant with handicap code but still get the door closed. You could have an unusual application where lots of air or air moves through the building when this door is open, and it just can't get the door closed because you've got the spring set so low, is the bottom line. So be mindful that that could be an issue that you get into. And we have had, surface closers, overhead concealed floor closers that just can't get the door closed because of these excessive environmental conditions. So be mindful that, at the top of the installation instructions, they're saying a reduced opening force equals a reduced closing force. So be mindful of that. The rest of page 1 goes over the 3 primary mounts. We're going to hit those right now. Regular arm, that's when you're mounting the body on the door on the pull side of the door. An application for that would be very typically a restaurant. You walk to the bathrooms, ladies to the left, gentlemen to the right. Those doors swing in. You don't want to see the closers on the restaurant side. Put them inside the bathroom. Those doors swing in. Regular arm is perfect. Be mindful in regular arm installations. Sometimes when you get that door open to 90 degree, the projection of the door closer body may hit a perpendicular wall. So look at that before you attach everything, because you might find that you can't get the door open because the cover will hit that wall. In an event like that, you're going to need to rethink where the closer is mounted, probably in a parallel arm fashion. Then you've got a top jamb mount. Where you're going to see that one all the time is going to be your favorite coffee shop. Those doors swing out, they mount the body up onto the header of the frame on the inside of the building, which is where you'd want it, because it's an exterior door, and that arm's going to be mounted to the face of the door. Top jamb installations will often get into the need for drop plates because you may not have enough dimensional space to fit a door closer body onto. And drop plates are very common, used to get the body mounted to a door or a header. Whether you're constricted by header height or top rail height, the amount of glass that's in the door. But a top jamb mount is going to be seen in that application. And is a very good way to, a very efficient way to get a door installed and closed. The last way is very common, parallel arm. You're going to see that on the back of a strip mall, the steel doors that are in the back that the business will take deliveries. Closer mounted on the inside, on the push side. Why not just install it in a top jamb fashion? You probably don't have enough room on the header to get a 7500 installed, and you don't have the drop plate, and don't want to buy the drop plate, which is an added cost, not insignificant. And you just install it in a parallel arm. The downside of the parallel arm is that because of the way that the arm, the main arm, works geometrically with the forearm attached to the header and to the door, you lose one size of efficiency. The closer has to work harder to do the same amount of work because of the orientation of the parallel. This is the main arm, from the shoulder to the elbow. The forearm is the forearm. The forearm is the portion that goes from the arm shoe or the parallel arm bracket to the elbow, and then up here is where the pinion shaft would be. So that's where main arm and forearm comes from. Because of the parallel nature of the main arm, the closer is not able to mechanically as effectively pull the door closed. So you'll notice in the installation instructions for parallel arm that you have to increase the amount of spring tension to effect the same net movement on the door. Meaning, if you had a top jamb mount installation for a 4-foot door on an outswing, you would set the spring to so many turns. If you had the same 4-foot door in a parallel arm fashion, you would have to add more spring tension to that installation just because it's a parallel arm. Just be mindful of it, and you will definitely bump into that. Page 2 is a discussion of the components. We've gone over that. Your body, your arm, your PA bracket, called a soffit bracket. If you hear the term soffit, a lot of us call it a stop. And it is the stop of the frame, but the specific location where it would attach to would be called the soffit. Screw package, cover, you're all good. There is a table of the fasteners that are included. Nice to have. You probably want to separate those out when you open the door closer body, just so you can focus in on, that's what I need. The ones you're not going to use, put aside. Eliminate the possibility of wasting time. There is a definition of an understanding there that the door needs to be operating healthily before you install the door closer. If the hinges are incredibly worn, replace them. If you've got friction, metal wearing on metal, the closer is not going to be very effective. You have to have a free swinging, healthy operating door. Your door and frame must be properly reinforced to receive a door closer. This closer does not include sex bolts, through bolts. If you've got a fire-rated wood door that's not reinforced, don't even attempt to install this without ordering from us the sex bolt package for this. You will have to have those, mandatorily, if the door is not reinforced. Be mindful that having sex bolts through the door may be a problem, so check with the authority prior to drilling holes through the door. If it's a steel door, they're probably already reinforced, but if you're ordering the steel doors, specify them as reinforced. The header is never by default reinforced for the body or the arm, so that has to be specified, and if it's not reinforced, you really have a problem. You'll need to think of an alternate solution to get the body or the arm attached to the header. Some people use jack nuts and things of that nature. I've even seen people through-bolt it through the entire header. Regardless of how it's done, it has to be secure to take that door closer body. Door closer should never be installed on the exterior of a building, even though it's got Nor-Glide fluid, not intended to take the Chicago winter and expect that fluid is going to be viscous enough to operate. You'll have internal components, corrosion resistant or not, that are just not going to work reliably in that application. So we've gone over the contents, we've gone over the summary. Now we've got 3 pages of regular arm, top jamb, and parallel arm. I'm not going to go through them in detail, except to point out what I have found to be the most important thing when installing a door closer. First of all, observe the installation instructions when it's telling you what end goes towards the hinge. It's not the same for all closers. You'll notice that all 3 installations tell you to install the tube end away from the hinge. So this is going to point towards the lock side for the regular arm, for the top jamb arm, and then for the parallel arm. It's all the same. That's not the case for all door closers. There are closers where you flip them over. In the case of Rixson, they're sister companies with Norton. In the case of this, for a certain hand of door, you're just simply going to turn it over, where the valves will be towards the top in some instances, and in all other instances they'll be pointed towards the bottom, and that simply relates to the hand of the door. Observe the instruction that the tube goes away from the hinge, and then are the valves up for a right-hand door or are they down for a left-hand door? You're going to notice that changes with the installation type. Regular arm has the valves up for a for a right-hand door. But if you're doing a top jamb mount, the valves are going to be up for a left-hand door. Okay, so just know how the body is oriented and know how it's oriented, what side the valves are up. That's important. The next important thing in installing a door closer for any of these three mounts is going to be, you'll always notice that you have an A dimension and sometimes a B dimension. The A dimension. The A dimension is the dimension from the vertical line of the vertical axis of pivoting, the center of the hinge, to where this first screw hole is on the body. The hinge barrel, the center line to the first hole. That's directly related to the degree of opening you want the closer to go to. How far away it is from the hinge is exactly how that's determined. You scooch it really close to the hinge, you're going to be able to affect a greater degree of opening than if you pull it away from the vertical axis of pivoting of the hinge. That table is for all three mounts, and the A dimension will change in relationship to what degree it's opening to 100 degree. Okay, so you're going to go just past 90. Or you want something to go out to 150 degree. You move it closer to the, you decrease that A dimension. That's where you start next with all of these. Once you know the A dimension, you can look at the drawing and determine all other locations of the holes that you have to provide to install the door closer. The other and likely final important calculation, in my opinion, A is important, but let's face it, if you're off a 1/4 inch, you're not really affecting too much. Although it's important to get it exactly right, the real important dimension are the vertical dimensions. For instance, if you've ever walked through a door and you hear a clanking sound, well, that could be the arm not fit very well on the top of the body, because those do loosen with time. But it could also be where you have an improper vertical dimension. If you look at the regular arm mount, our restaurant bathroom example, that the vertical dimension is 3/4 inch from the top of the door to the top of the first hole. And then you've got your A dimension. That's where that first hole is going to be. From that drawing, you can lay out all other holes. Be mindful that there are some solid circles there. Those solid circles may be defined, yeah, okay, they are. That is for a back plate or a drop plate. If you are attaching the closer to a drop plate, that's where those holes will have to be drilled to mount the plate. In your mind's eye, imagine that the top rail of the door is 2.5 inch or 3 inch. You could see that you're not going to have enough real estate on the top of the door to get the bottom holes installed. Therefore, well, this may be a bad example. No, it's not. It's actually a perfect example. Therefore, you would attach the closer, the closer body. You would attach the drop plate to the door per those dimensions. Attach the body to the drop plate, and now your closer will fit on the door. Okay, that's a great example. But the 3/4 inch dimension is crucial, along with the 1.125" dimension showing you how far up to come for the shoe of the arm, where you're going to locate these holes. Okay, in my experience, the vertical dimensions are most important. That's going to be the difference between a proper working closer and an improper working closer, and frankly, there ain't no way to fix that. If you're off a 1/2 inch, you've got a big problem. You have to re-drill holes. So get the vertical dimensions accurate. And then after that, the last thing to do is to digest and understand controlling the valves and what they do. I suggest get the door closer put up there, cycle it. Observe it. Does it work exactly how you want? Leave it alone. If it doesn't, make adjustments to not only the spring, but also to the valves as well. Okay, it comes out of the factory. set for the most common of installations, so it's probably going to be that yours is going to be perfect. But on the final page of the installation instructions is where they define everything specifically. I had said the back check was at about 85 degree. I noticed the term back check fluctuates a little bit depending on the closer, the type of closer. Like back check for an automatic door operator is different than back check on this in terms of, that might be 70 degrees for a automatic operator. You get out to about 85 degree for a hydraulic closer. Understand what the valves do. Make very small adjustments. Then cycle the door 2 or 3 times. Okay. The good thing about a door closer over spring hinges is the fact that you can control the door. A spring doesn't control the door. It just tension, set, tension, 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 release, 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 close the door. That's not really helpful when you have a condition that you want to be able to tailor over time. Think of a northern climate, or for that matter, a southern climate when it gets windy certain times of the year, like real windy, or air pressures. You could have a front door of a 3-flat in Chicago, and in the summer, the tenants have the back windows open because it's beautiful outside. Well, the landlord might come and adjust that closer so it's not slamming so hard. Or you need to effect a little greater closing force to get the door to latch because you've got an electric strike installed. The ability of a door closer to have you, with the possibility of controlling it, changing it via the valve settings with your Allen wrench, which is included, is a hallmark of why you would always want a door closer over a spring hinge. But understanding how you affect the valves, the spring tension, that's here. Careful with that. Get a proper fitting wrench. You don't want to wear that out over time. I would use a box wrench, and I would keep one only for using this. And then again, the details are indeed, they show a crescent wrench. The details are indeed all defined here. The power adjustment, really. And you're probably only going to set that once and never have to set it again. But you might need to change that a little bit. I doubt that'll be the case. Regarding installation and the A dimension, the vertical dimension, I have machined doors, steel and wood, I think for every possible piece of hardware that exists. If you're going to do one and you've got a template and if you're going to do a double acting bomber spring hinge and you've never done one before and you're only going to do one and don't expect to ever do one again, lay out the door, lay out the template, and make all your preparations, your mortising, your routing, whatever it is. You have a job where you're going to put in 15 of these door closers. I would really recommend that you make a template. Get a piece of 1/2-inch poplar or whatever. Cut it into a rectangle. Drill holes through it so that you can use a center punch and mark the holes. Square that up to the inside of the jamb. Make your adjustments for the jamb, the stop height, the stop projection, etc. And eliminate the possibility of making mistakes measuring 15 times. Put that piece of wood up there. Maybe get yourself another piece that's 90 degrees so you can mark the header if you're doing the soffit, if you're doing a parallel arm. Mark, 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 center punch, center punch, center punch, drill, 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 and you're off to the races. You could be on a ladder, on a step stool, drilling, marking, and drilling all these holes, and someone can come behind you and just doing the physical attaching. When you automate the process like that, even if you're doing whatever. If I was going to do more than 3, I end up making a template because I usually find that I'll encounter the same closer again in life. You could take that template, you can mark on it, and you can, whatever you want to do. We can also sell you professionally manufactured templates for putting these in, and we don't sell them often, and that's because they last the lifetime of the owner having the template. And of course, Norton 7500, we can sell those to you. Finally, there's a link below this video to the manufacturer's page where you can pull up not only all of the Norton products we sell, but a link to the manufacturer's website, as well as a link to the full product catalog. I'm a fan of Norton. They may not be my favorite, but they are an excellent company with good quality people and good quality products. Thank you very much.